All right, so today we're diving into something pretty fascinating, I think.
Yeah.
And that is how we can use technology to shake up science education.
Yeah.
Specifically, we're going to be looking at this idea of scientific inquiry in educational multi-user virtual environments.
Catchy title.
Yeah, it's a mouthful, isn't it?
Yeah.
But thankfully, we have this paper by Brian C. Nelson and Diane Jass Kettlehut, published back in 2007 in Educational Psychology Review,
Right.
and they kind of unpack it all for us.
Yeah, they break it down.
So we're basically going to be trying to figure out if these virtual worlds, these
Right.
online spaces can really help students do real science.
Yeah, like actual investigations and stuff.
Exactly.
Like, can we finally make that happen?
Can we make that happen?
Because it's been a goal for a long time, right?
Yeah, you're right. It's not a new problem.
Like for decades, the education world has been saying
Yeah.
students should learn by doing.
By doing it.
Hands-on.
Hands-on.
Inquiry-based learning.
Inquiry-based learning.
Figuring things out on their own.
Yeah, asking questions,
Exactly.
experimenting, all that good stuff.
But it's hard.
It is hard.
It's tough to actually put that into practice in a classroom.
This paper really highlights that
It does.
this gap between the ideal and what actually happens.
Yeah, like what's actually going on the ground.
Right.
And there's a few reasons for that.
Right. Yeah, there are a few reasons.
One that I found surprising was the fact that a lot of K-12 teachers,
Especially in science.
especially in science, don't actually
You have a strong science background themselves.
Yeah, that's a tough one.
Which makes it hard to
Yeah,
design those activities.
exactly. Right.
So they end up relying more on textbooks and structured lessons.
Yeah. I mean, it makes sense.
Yeah.
If you don't feel super confident in a subject, you're
Yeah.
going to stick to the
script.
script.
Yeah.
But the problem with that is those textbook activities, even though they're about science, they don't really capture the essence of inquiry.
Right.
They're not about, going out there and exploring and not knowing the answer.
Yeah.
They're more about confirming.
Yeah, they're more like, here's the fact.
Here's the fact.
Let's prove it.
Let's prove it.
And that's not really
How science works.
That's not really how science works.
It's not about the process of discovery.
It's not about the journey.
Right.
Yeah.
It's about the answer.
Yeah.
And that's where MUVEs come in.
That's where MUVEs come in.
Maybe they can change that.
Okay, so what
Yeah.
exactly
What are you talking about?
are these MUVEs?
Yeah.
Educational multi-user virtual environment.
Big words.
Big words.
Basically, online spaces,
Mhm.
simulated worlds.
Right, where you have an avatar.
Yeah.
You're interacting with other people.
Right. And these researchers want to know
Yeah.
if we can step into these digital worlds.
Right. These virtual labs and these virtual field trips and overcome these obstacles.
Yeah. Yeah. Like, can we
Yeah.
we really do science?
Do science in this digital world.
Right.
So for you,
Yeah.
someone who really likes to learn things thoroughly
Yes.
and quickly and get to the bottom of things.
And have those aha moments.
Exactly.
Yeah.
Does this sound exciting to you?
I mean, it sounds pretty cool so far.
Because that's what we're diving into, right?
Yeah, that's what we're diving into.
Like, can these virtual worlds actually capture
Yeah.
what makes science science?
And make it more accessible to people.
Exactly, right.
Yeah. Okay. So
Okay.
let's get into the first key idea here.
Okay, shoot.
How can MUVEs support real-world inquiry?
Yes, the big question.
The big
I
question.
mean, the paper basically argues that
Yeah.
if you design these virtual environments well
Right.
and you give them good tools, virtual tools,
Yeah.
then they can actually lead to authentic inquiry practices
Right. Because you're interacting directly
directly.
with this simulated world. It's like a hands-on experience,
It is.
but in a digital space.
In digital space, yeah.
And they connect this to the National Science Education Standards,
Oh, interesting.
which is pretty cool. Like, they're really looking at this,
They're grounding it
grounding it, yeah.
in the real world.
In the real world, like,
Yeah.
how do we actually define scientific inquiry?
Okay, so how do we define it?
Well, it's a lot of things, right? It's making observations.
Okay.
It's asking questions. It's examining sources, of, doing research.
Yeah.
It's planning investigations.
Right.
It's using tools to gather data. It's analyzing that data.
Okay.
It's proposing explanations based on what you find.
Right.
And then it's communicating those results.
So it's the whole process.
The whole shebang.
Yeah, the whole shebang.
And the paper argues that MUVEs can actually support all of those aspects.
Okay, so let's see. Let's break it down.
Yeah, let's do it.
How can MUVEs help with making observations?
Well, they talk about this cool scenario in Yville.
What is white?
Yville is a virtual world.
Okay.
And they have this thing called YPOX.
YPOX.
Yeah, it was like a virtual disease outbreak.
Oh, wow.
And students could actually see,
the symptoms?
yeah, on their avatars.
On their
Because
avatars.
they would show up visually,
Interesting. So they're directly observing.
directly observing this phenomenon.
Yeah, that's cool.
A really engaging way to start thinking about disease.
To feel like
Right.
that.
And then when it comes to asking questions,
Yeah.
MUVEs let you interact with NPCs, non-player characters.
Oh, right, like the computer controlled.
Computer control characters.
Yeah.
But also they can interact with other students
Other students in the virtual world.
in the virtual world.
Right.
So you get that social element,
Right.
which could be really powerful for sparking curiosity.
Yeah, because you're talking to someone.
Yeah. And you're like, wait, what's going on? I need to figure this out. I want to find out more.
Exactly.
What about information gathering? Well, MUVEs can have virtual libraries, classrooms, all sorts of resources built right
Right there in the world.
there in the world.
So you can just go and look stuff up.
Exactly. So it's like a scientist consulting research, right?
Yeah. You don't have to go outside the world to find information.
Exactly. It's all right there.
Okay, that makes sense.
And then we get to the really fun part,
Okay, what's that?
virtual tools.
Oh, yeah, that's right.
Like in River City, they had virtual microscopes, bug catchers, even disease simulators.
Oh, wow.
They had environmental health meters.
That's amazing.
Cool, right?
Yeah.
And these aren't just for show.
Right. They actually let you
Let you do stuff, gather data, analyze it
in the world.
in the world. Yeah, so it's not just about reading about science.
Right. It's about doing it.
It's about doing it.
Yeah.
And some MUVEs even let you manipulate variables.
Oh, wow.
Like in River City, you could actually change things and see what happened.
Like a real experiment.
Like a real experiment, yeah.
That's amazing. You can't really do that in a classroom.
No, not really. Not to that extent.
Yeah.
And then, because these MUVE activities happen over time,
Right.
you can revisit your hypotheses, refine them
As you get more data.
as you get more data.
Yeah, which is how real science works.
Exactly. It's iterative.
Yeah.
You're constantly learning and adjusting your thinking.
So what about communicating your results?
Yeah.
How do you do that in a MUVE?
Well, you can have virtual newspapers, presentations, even collaborative charts.
So you're still sharing your findings
You're still sharing, yeah,
with the community
with the community. But it's all happening in this digital space.
in the digital space.
Yeah.
Okay, so
Okay.
when we think about all these challenges
Yeah,
to bringing inquiry into the classroom,
right.
it seems like MUVs have the potential to be pretty powerful.
I think so.
They really seem to capture that spirit of discovery.
Yeah, that exploration.
Yeah, that's really cool.
It's exciting.
Yeah, it is exciting.
All right, so let's move on to the second key theme,
Okay.
which is all about gender and engagement.
Right. Do these MUVEs appeal to girls and boys equally?
Yeah, that's the question.
The question.
And the paper says, yeah, they can.
They can.
Yeah, like these virtual worlds can be really compelling for both boys and girls.
So they're saying
They are.
it's equitable.
It is. There's evidence from studies on Moose Crossing, River City, Quest Atlantis.
All these different MUVEs.
Different ones, yeah.
And they're all showing
No significant differences
in learning outcomes.
between boys and girls.
Between boys and girls, that's really good.
A really good sign, right?
Yeah. For STEM education.
STEM education, yeah.
Yeah.
But there's a twist.
There's a twist. Okay.
Some studies did find differences in how boys and girls engaged with the MUVEs.
Interesting.
So the outcomes were similar,
Right.
but the way they got there was a little different.
How so?
For example, in Moose Crossing, girls spent more time communicating.
More time talking to each other.
Yeah, interacting with other users. And in Quest Atlantis, they were more likely to use chat and email.
And write more in their online notebooks.
Exactly.
So they're engaging differently,
Differently. Yeah.
but still learning the same amount.
It seems that way, yeah.
So why might that be?
Well, the paper connects this to ideas about how to design software that appeals to girls.
Okay.
And it turns out a lot of MUVEs already have those features built in.
Really?
Yeah, things like rich narratives, customizable characters,
Okay.
opportunities for collaboration and social interaction, even design and creation elements.
So it's almost like MUVEs are
Yeah.
accidentally.
Accidentally girl-friendly.
Yeah, girl-friendly.
But it works, right?
It works.
It seems like these design elements make a more equitable learning space.
For both genders.
Exactly.
Okay, so that's pretty cool.
It is.
But now we're getting to a more nuanced theme.
Okay.
Uneven student engagement.
Yeah, this one's interesting.
It is interesting because the research shows
Yeah.
it's not always consistent.
Right. Some studies show great engagement.
Some show less.
Less so.
Yeah. What are some examples?
When at Moose Crossing, a lot of students didn't do the programming activities.
Okay, so they weren't fully participating.
Yeah, they weren't fully engaged.
And then there was that informal use of Yville during YPOCs.
Right, when it wasn't tied to a specific curriculum.
Yeah?
Not a lot of students actually did the investigation.
Okay.
But then you have the Wolfden graduate course,
Yeah.
which was entirely in a MUVE.
And everyone built a game.
Everyone built a game. They were super engaged.
That's awesome.
And the classroom-based YPOC's curriculum.
When it was part of a class.
Yeah, students were much more involved.
So structure seems to help.
It seems to, yeah.
What about River City?
River City had high motivation,
Okay.
but not everyone used the optional guidance systems.
Interesting. So even within a well-designed MUVE,
Yeah.
you still get some variation.
You do.
So what could be causing these differences?
That's the million-dollar question, right?
And it is, yeah.
The researchers suggest maybe MUVEs are too open-ended.
Too much freedom.
Too much freedom for some students.
Yeah, it can be overwhelming,
It can be.
especially if you're used to more structure.
Right. And they also talk about the difference between formal and informal learning.
So in school versus outside of school.
Exactly. And it seems like when MUVEs are part of a curriculum,
Yeah.
the engagement is higher.
Maybe because the goals are clearer?
It could be, yeah.
Or there are expectations and deadlines?
Yeah, accountability.
Accountability, right?
So this uneven engagement,
Yeah.
it shows that we need more research.
We need to figure out what works.
What works and why?
Yeah.
Like what specific design elements?
Yeah, which features?
Which features really make a difference?
Yeah, and for whom?
Exactly.
So it's not just about throwing students into a virtual world.
No, it's more nuanced than that.
Right, you have to think about design, pedagogy, the learning context.
A whole package?
It is a whole package.
All right, so the paper then talks about some unanswered questions
Okay.
and areas for future research.
Right, because there's still a lot we don't know.
There is.
And one big area is teacher support.
Ah, yes, the teacher.
The teacher.
The unsung hero.
The unsung hero of education.
Because they're the ones who actually have to implement all this.
Right.
And the research hasn't really looked at,
Hasn't really looked at how MUVEs can support teachers.
yeah, like can they help teachers meet those state and national science standards?
Right, because it's not enough for it to be fun and engaging.
It's not.
It has to align with the curriculum.
It does. And can MUVEs help teachers learn how to do inquiry-based teaching?
Right. Can they be a model for teachers?
A model or even a training ground
Yeah.
where they can practice those skills?
That's a really good point.
Because if the teachers aren't comfortable with inquiry,
Right.
it's not going to work.
It's not going to translate to the students.
Exactly.
So future research should definitely look at this.
Definitely.
How to support teachers.
How to support teachers using MUVEs.
Okay, so what are some other areas for future research?
Well, they want to know how viable MUVE-based inquiry is.
As a replacement for real-world inquiry.
As a replacement, yeah. Can we achieve the same learning outcomes in a virtual setting?
Okay.
Or even better outcomes?
That's a big question.
It is. And what about underserved students?
Yeah, can MUVEs help bridge the gap in access to inquiry-based learning?
Right, because not everyone has equal opportunity.
And that's a problem.
It is.
So can MUVEs level the playing field?
That's the hope.
Okay, and then there's the question of specific features.
Right. Which ones are the most effective?
Yeah, like those virtual experimentation tools.
The scaffolding, the things that keep students engaged.
We need to know what works.
We do. And for whom?
And for whom?
And of course,
More research on teacher support?
always more research on teacher support.
So this paper really paints a picture of the potential of MUVs.
It does.
It's exciting to think about how they can change science education.
It is. The access to authentic inquiry. The engagement for diverse learners.
And potentially even greater gender equity.
It's a lot of potential.
It is.
But we also have to remember,
Yeah,
this is still a developing field.
there's still a lot to learn.
There is. We need to figure out how to ensure engagement for all students
Right, not just some.
and how effective they are for different types of learners.
And how to support teachers.
The teachers are key.
They are.
So this has been a really interesting deep dive.
It has.
And it leaves us with a final thought for you.
What's that?
After learning about these virtual learning environments,
Yeah.
what other fields could benefit from this immersive, interactive approach?
Ooh, that's a good one.
Like, could we use these principles
Science education?
to learn about history or literature or anything really?
Anything. Yeah.
It's a pretty thought-provoking question.
It is.
So we'll leave you to ponder that.
Yeah, think about it.
Thanks for joining us.
Thanks for taking this deep dive with us.
See you next time.
See you next time.